Hi, I'm Gevorg Nazaryan from Alekhanian National Science Laboratory, and in this presentation, I will talk about medium-induced modification of kaon spectra measured in semi-inclusive DIS at HERMES on the basis of HERMES collaboration. Here is an outline of my talk. We will cover the theoretical motivation of this work, how we did our data selection. We will see obtained result in the course design. When we speak about suppression of hadron spectra, we need to keep in mind that for the pions and for K plus, we have suppression of spectra, but for K minus, we have an opposite effect. We have enhancement of K minus spectrum. It is well known that the K minus in general can come from a valence quark shower evolution and from the Cia quark. And how can K minus enhance? And there is some article where for this question, the answer that this can be enhanced due to medium-induced flavor conversation, but it is required the large X and Z. How we can theoretically and experimentally measure the hadron spectra enhancement? So we can do it via defining nuclear modification factor R, which is defined in terms of ratio of hadron yields per DIS event for a nuclear target A to this for a deuterium target B. Nuclear modification factor is depending from many variables. Most important for us is the X, which is the fraction of the nucleus momentum carried by the quark. It's called the Broken variable. Hadron fractional energy, it's a Z, and PT is the transfer momentum of produced hadron. N, E, number of DIS electrons, and NH is the number of SIDIS hadrons. Here is the article mentioned earlier. On the left plot, it's showing nuclear modification factor depending from Z when X equal to 0.1. On the right plot, it's showing the nuclear modification factor depending from Z when X broken is 0.5. And this is our interested region. So the aim of this analysis is to experimentally support this theoretical prediction. Yeah. So we use the deuterium, neon, krypton, and xenon target for this study. Here we can see the cuts used for the analysis, also defined for double binning over X broken and Z. Here is my obtained result for nuclear modification factor depending on Z for the 5X broken slices on the right hand side for K minus and on left hand side for K plus. Here we can see that for the bottom left plot for K minus we have the enhancement. On the next slide we can see the comparison of experimental and theoretical result, and from here we can say that obtained result is supporting theoretical prediction. We can see that for the K plus we have the point that are below unity, and for K minus point that are above unity. That means we have enhancement here. Here are the plots that show the super ratio, which is the ratio of nuclear modification factor for K minus over K plus. And we can see that the red points for krypton target is above a unity. Summarizing, we can say that for K minus in case of the krypton target and X working greater than 0.45, certain indication of enhancement for nuclear modification factor, which is with the increasing of C is absorbed. Super ratio at highest Z and X can become even greater than unity for krypton.